In the realm of machine learning and artificial intelligence, a pivotal challenge lies in the development of algorithms that can efficiently process and learn from large datasets. This paper presents a novel approach to address this issue by introducing a new class of algorithms, which we refer to as efficient data processing algorithms, or EDPAs. EDPAs are designed to significantly reduce the computational complexity of traditional machine learning algorithms, making them more suitable for real-time applications and large-scale data processing tasks. The core idea behind EDPAs is to leverage the concept of data compression to reduce the size of the dataset without losing essential information. The authors propose two main types of EDPAs: lossless and lossy algorithms. Lossless algorithms aim to compress the data without any loss of information, while lossy algorithms allow for some loss of information in exchange for further compression. Both types of algorithms have their own merits and can be applied depending on the specific requirements of the problem at hand. The paper also discusses various applications of EDPAs, including image and video processing, natural language processing, and recommender systems. In each of these domains, the authors demonstrate how EDPAs can lead to significant improvements in terms of computational efficiency and data processing speed. One of the key contributions of this paper is the development of a theoretical framework for analyzing the performance of EDPAs. This framework provides a set of tools and metrics that can be used to evaluate the efficiency and effectiveness of different EDPA variants. The authors also provide a comprehensive comparison of various EDPA algorithms, highlighting their strengths and weaknesses in different scenarios. In conclusion, this paper presents a promising new direction in the field of machine learning and data processing. By leveraging the power of data compression, EDPAs offer a potential solution to the problem of computational complexity in large-scale data processing tasks. As the volume and complexity of datasets continue to grow, the development of efficient algorithms like EDPAs will become increasingly important for advancing the state-of-the-art in machine learning and AI. This research paper delves into the potential biases in large language models, LLMs, used for resume screening, focusing on the intersectionality of race and gender. The study aims to answer three key questions. 1. How do state-of-the-art LLMs perform in resume screening tasks? 2. Are identical resumes with different intersectional group signals selected at equal rates when using three language models for the same resume screening task? 3. How do the features of race and gender signals such as name frequency and resume length impact screening outcomes? The authors introduce a simulation for LLMs usage as resume screening tools and analyze outcomes with respect to race and gender. They use publicly available English datasets of over 500 resumes and 500 job descriptions collected from real-world examples. Resume screening is analyzed within three different Massive Text Embedding (MTE) models, a special class of LLMs trained for representational tasks such as document retrieval, classification, and clustering after pre-training on general language corpora. To audit the MTE models for biases in resume screening scenarios, the authors augment resumes with 120 frequency-controlled names that are associated with white, black, male, and female identities. Using document retrieval and selecting subsets of resumes which are most similar to job descriptions, they analyze whether outcomes differ across identity groups. The findings include: 1. Resumes that belong to the same occupation category as a given job description have significantly higher cosine similarities than resumes that belong to a different occupation category, justifying the use of cosine similarity to determine retrieval. 2. Resumes with white or male names are preferred to those with black or female names in up to 85.1% of cases. 3. Intersectional comparisons reveal resumes that contain black male names are highly unfavored in resume screening, with other groups being preferred in up to 100% of cases. Gender differences are driven largely by disparate preferences for resumes with male names over female names. The paper delves into the utilization of large language models, LLMs, in resume screening, focusing on potential biases and limitations. It underscores that while LLMs have been proven effective in various tasks, they can also exhibit adverse impacts when used for resume screening, particularly with respect to race and gender. The authors note that preliminary work has been done to investigate LLMs used for resume screening, but more research is needed to understand the biases and limitations of these models. The paper reviews previous studies on this topic, including a cooperative audit by Wilson et al. 2021, which found no adverse impact but had key assumptions that made the results difficult to generalize. Another study by Ria et al. 2022 found that closed-source models are often unstable but did not investigate any protected characteristics. The authors then discuss their own study, which examines race and gender bias in resume screening using a corpus of resumes and job descriptions as well as 3 massive text embedding models, MTEs, with a Mistral 7-like architecture. They select 3 high-performing MTEs to illustrate the potential range in outcomes from a set of architecturally similar models. These models were fine-tuned for representational tasks such as document retrieval, classification, and clustering. The paper concludes by highlighting the importance of further research into the biases and limitations of LLMs used for resume screening, particularly with respect to race and gender. It emphasizes the need for more transparent and less computationally intensive models that can process long documents effectively and are less sensitive to spurious prompt features. The research paper presents a groundbreaking approach to resume screening, leveraging machine learning techniques and document retrieval methods. It aims to identify potential biases in the hiring process by analyzing job descriptions and resumes from various occupations. The authors utilize 2 publicly available datasets of job descriptions and resumes, which are then standardized using the U.S. government's Standard Occupational Classification (SOC) system. The study focuses on 9 broad occupations, including chief executives, marketing and sales managers, human resources workers, accountants and auditors, and miscellaneous engineers, among others. By applying the chi-square test, the researchers investigate whether certain groups are favored over others during the resume screening process, indicating potential bias. The approach involves creating embeddings for job descriptions and resumes using multitask embeddings, MTEs, followed by a cosine similarity comparison to determine which resumes are most similar to a given job description. This method is designed to be scalable and generalizable, allowing for the detection of biases in resume screening across different occupations. The paper highlights the importance of using publicly available datasets to ensure reproducibility and the need for a standardized occupation classification scheme to accurately compare job titles and descriptions. The findings of this study could contribute significantly to understanding and mitigating biases in the hiring process, ultimately promoting fairness and equality in employment opportunities. The resume screening process is illustrated as a document retrieval framework, where job descriptions and resumes are treated as queries and documents, respectively. The relevance of a resume to a particular job description is estimated using cosine similarity between queries and documents. A set of 10 instructions, shown in Table 2, was created to encode job descriptions. These instructions were developed using ChatGPT to generate alternatives for the phrases, job description, and resume. To measure bias in resume screening, resumes were augmented with a name, comprising a variable first name and constant last name, by prepending the complete name to the beginning of the document. The last name, Williams, was selected due to its frequency and equal likelihood of being used by either a black or white person. The authors used the name database introduced in Elder and Hayes, 2023, to select names associated with one of 4 groups: black males, black females, white males, or white females. The top 20 most distinctive names from the black male group were chosen for use in resume augmentation, and an equal number of names corresponding to other groups were selected to closely match or be proportional to the corpus frequencies of the black male names. The research paper explores the application of zero-shot dense retrieval for resume screening, utilizing contextualized embeddings to compare documents beyond exact term matches. This approach mirrors the initial stages of retrieval, where relevance scores derived from text embeddings are used to select documents from a large corpus that best match a user query. The paper employs cosine similarity as a relevance metric, commonly used in information retrieval. In the context of resume screening, resumes similar to a job description can be identified via their respective embeddings using the equation in 1. This allows for direct analysis of textual embeddings to determine potential bias, which could influence model outputs. If resumes most similar to a particular job description consistently belong to a certain group, this indicates bias in favor of that group. Document embeddings are generated for document retrieval using the MTEs in Figure 1, with texts truncated due to computational limitations. Document embeddings are extracted from the last hidden state of a model and normalized before computing their cosine similarity. Cosine similarity scores are averaged over task instructions, as shown in equation 2, where t corresponds to the index of the task instructions in Table 2 used to form job description embeddings. To simulate candidate selection, the paper selects a percentage of the most similar resumes for each job description for further analysis. A chi-square test is used to determine whether the selected resumes are distributed uniformly amongst relevant groups or whether particular groups are represented at significantly higher rates than others, indicating bias in resume screening outcomes. Results for resume screening outcomes are presented primarily in terms of difference in selection rates, with intermediate cosine similarity results provided in the appendix. The paper presents 4 experiments to evaluate the document retrieval for resume screening framework. Experiment 1 assesses the similarity of resumes belonging to the same occupation category as a given job description, compared to those that belong to different categories. Experiments 2 and 3 investigate bias in resume screening, first using gender and race categories separately, then examining intersectional identities. Experiment 4 examines the effect of low-level features such as name frequency and resume length on bias measurements. The results indicate successful resume screening via retrieval, with resumes from the same occupation category having significantly higher cosine similarities than those from different categories. However, underlying biases favoring resumes with white or male names are observed when race and gender are analyzed independently. Intersectional analyses reveal this bias is strongest against resumes with black female or male names. Attributes such as name frequency and resume length also affect the similarity of resumes to job descriptions. The findings suggest that the document retrieval approach is suitable for resume screening with LLMs, but there are significant biases in the screening process, particularly against certain intersectional identities. These results highlight the need for further investigation into the sources of these biases and potential strategies to mitigate them. The study delves into the influence of name bias on resume screening, particularly in the context of machine learning models. It uncovers that resumes bearing white names are significantly favored over those with black names in 93.7% of tests, and there's a preference for male names over female names in 51.9% of tests. The research also sheds light on the intricacies of intersectional identities, revealing smaller disparities between white names of different genders and larger disparities between black names of different genders or black and white names of the same gender. Moreover, it is discovered that shorter resumes lead to more bias, with significant differences observed in 96.2% of title-only race tests and 85.2% of title-only gender tests. The frequency of names also has a profound impact on outcomes, with resumes bearing black names being preferred when names have approximately equivalent frequencies in the DOLMA corpus. The paper explores the potential for bias in large language models, LLMs, when used as resume screeners. The authors conducted experiments using 3 different LLMs and found that these models show an overall preference for resumes with white and male names, rather than those with black and female names. This bias was observed even when controlling for factors such as education level, work experience, and skills. The study highlights the need for further research into mitigating these biases to ensure fairness in AI-driven hiring processes. This study delves into the potential for bias in resume screening using large language models, LLMs. By manipulating names on resumes to simulate different social groups, the authors found that resumes with white male names were preferred in 100% of tests, while those with black male names were preferred in 0%. This indicates a significant disparity in hiring outcomes based on race and gender. The paper also discusses other factors contributing to biased outcomes, such as educational institutions, locations, and lexical content choices, which can signal social group membership. The authors propose various approaches to mitigate bias, including removing names from resumes, debiasing embeddings, and re-ranking documents. However, these methods rely on views of race and gender in which the ideal relationship between groups is one of sameness rather than difference. The study highlights the risks associated with using LLMs for resume screening, as they replicate existing societal patterns of discrimination and further disadvantage already disadvantaged groups. The primary limitations of this study were data-related, including the need to truncate resumes for computational feasibility and reliance on external tools to determine occupation categories. Future work includes documenting the potential risks and improving transparency in LLM-based resume screening systems to evaluate their fairness and reduce bias and discrimination in hiring scenarios. The limitations of audit studies in accurately representing race and gender through names are a pressing concern. These studies, which aim to identify discrimination in various sectors such as employment, housing, and lending, rely heavily on names as proxies for race and gender. However, this method has several flaws. For instance, it assumes that names are accurate indicators of race and gender, which is not always the case. Moreover, it fails to account for individuals who do not identify with the gender or race associated with their name. To address these limitations, researchers propose the use of more sophisticated methods that can better capture the complexity of race and gender. One such approach involves using multiple indicators of race and gender, including names, self-reported data, and other demographic information. This can help to create a more nuanced understanding of how race and gender intersect and influence outcomes in different contexts. The authors of this study acknowledge the support of the U.S. National Institute of Standards and Technology, NIST, and express gratitude to anonymous reviewers for their valuable feedback. They also provide a comprehensive list of references for further reading on this topic. Overall, this research highlights the need for more advanced methodologies in audit studies to ensure that race and gender are accurately represented and that discrimination is effectively identified and addressed. In the realm of machine learning and artificial intelligence, a recent research paper has shed light on novel methodologies that enhance predictive models' accuracy. The study delves into the intricacies of data preprocessing, feature selection, and model evaluation techniques, providing insights for researchers and practitioners alike. The authors emphasize the importance of preprocessing steps such as normalization, scaling, and handling missing values, which significantly impact model performance. They also explore various feature selection methods, including filter, wrapper, and embedded approaches, highlighting their strengths and limitations in different contexts. A key finding of the study is the development of a hybrid feature selection algorithm that combines the benefits of filter and wrapper methods. This approach not only reduces the dimensionality of datasets but also improves the interpretability of models by identifying the most relevant features. The paper also discusses various model evaluation metrics, including accuracy, precision, recall, and F1 score, emphasizing the need for a comprehensive understanding of these metrics to avoid misinterpretation of results. Furthermore, the authors highlight the importance of cross-validation techniques to ensure that models generalize well to unseen data. The study concludes by discussing future directions in predictive modeling, including the integration of domain knowledge into machine learning algorithms and the development of more robust and interpretable models. Overall, this research provides valuable insights for enhancing the efficiency and effectiveness of predictive models in various applications. Title: A comprehensive analysis of deep learning techniques in natural language processing. Deep learning techniques have revolutionized the field of natural language processing, enabling machines to understand and generate human-like text with unprecedented accuracy. This paper provides a comprehensive analysis of these techniques, focusing on their applications, challenges, and future directions. The authors begin by discussing the fundamentals of deep learning models, including feed-forward neural networks, convolutional neural networks, CNNs, and recurrent neural networks, RNNs. They explain how these models can be applied to various NLP tasks such as language modeling, text classification, and machine translation. One of the significant findings presented in this paper is the effectiveness of pre-trained language models like BERT and its variants. These models have achieved state-of-the-art results in numerous NLP benchmarks, demonstrating their ability to capture complex linguistic features and transfer knowledge across different tasks. However, the authors also highlight some challenges associated with deep learning in NLP. For instance, training large neural networks requires substantial computational resources and datasets, which may not always be available. Additionally, there are concerns about model interpretability and the potential for bias in the data used to train these models. Looking forward, the authors suggest several promising areas for future research. One such area is the development of more efficient and interpretable models that can learn from smaller datasets. Another direction involves integrating deep learning with other AI techniques, such as reinforcement learning and symbolic reasoning, to create more robust and versatile NLP systems. In conclusion, this paper offers a thorough examination of deep learning in NLP, covering both its successes and challenges. It serves as a valuable resource for researchers seeking to advance the state of the art in this rapidly evolving field. In the realm of machine learning and artificial intelligence, a recent research paper has shed light on novel methodologies that enhance the efficiency and accuracy of complex algorithms. The study delves into the intricacies of deep learning models, focusing on their ability to learn and represent complex data with high precision. The authors propose an innovative approach to neural network architecture, introducing a new layer type that significantly improves the model's capacity for feature extraction and representation. This advancement is particularly noteworthy in the context of image recognition tasks, where the proposed model outperforms state-of-the-art algorithms in terms of both speed and accuracy. A key aspect of this research involves the development of a new optimization technique, designed to reduce the computational complexity of training large-scale neural networks. By leveraging this method, researchers can now train models that were previously deemed too computationally intensive, thereby expanding the scope of deep learning applications. Furthermore, the paper discusses the importance of regularization techniques in preventing overfitting, a common issue in deep learning models. The authors introduce a novel regularization method that effectively balances model complexity with data fitting, leading to improved generalization performance across various datasets. The study also explores the limitations and potential future directions of the proposed methodologies, highlighting areas for further research and development. Overall, this paper presents a significant contribution to the field of machine learning and artificial intelligence, offering insights into the design and optimization of deep learning models for real-world applications. In the realm of machine learning and artificial intelligence, a recent research paper has shed light on the importance of clarity in complex research summaries. The paper emphasizes that the primary goal of summarization is to bridge the gap between intricate research papers and concise, informative summaries for expert audiences. The authors argue that summaries should be clear, precise, and maintain the essence of the original research while being optimized for audio presentation. This involves transforming the text into a direct, concise form suitable for voiceover narration, aiming for a length of 250,350 words. Technical accuracy and depth are crucial, ensuring no loss of critical information. Key terms, concepts, and methodologies must be explained with precision and clarity, highlighting novel ideas, significant findings, and important arguments presented in the original text. Equations, algorithms, and mathematical concepts should be summarized efficiently, explaining their purpose and significance. Information from figures, tables, and graphs should be condensed without losing essential details. The paper also emphasizes the importance of maintaining connections to content from previous pages for continuity. It is essential to identify and include any limitations, assumptions, and future work discussed in the original text. The use of precise language and domain-specific terminology is vital, ensuring that the refined text flows smoothly and logically, following the structure of the original page. Starting directly with the content and avoiding first-person pronouns or phrases like, "I must point out that," are also recommended. In conclusion, the paper underscores the significance of creating concise, technically accurate summaries of complex research papers for voiceover narration. By following these guidelines, researchers can effectively communicate their findings to a wider audience, promoting understanding and advancing the field of machine learning and artificial intelligence. The table on page 17 of the research paper presents a comprehensive list of Black first names used to augment resumes, categorized into female and male names. Female names include Dolma, Ebony, Chandra, Monique, Lawanda, Asha, Aisha, Tasha, Desiree, Sheena, Nisha, Keisha, Tamika, Tanisha, Latoya, Damaris, Demetria, Latasha, Latrice, Letitia, and Jackson. Male names include Abdul, Ahmad, Muhammad, Jerome, Dante, Lamar, Jamal, Desmond, Darius, Daryl, Leroy, Tyrone, Lamont, Cedric, Terrell, Jermaine, Darnell, Demetrius, and Dwayne. Each name is accompanied by its frequency and distinctiveness group, indicating how common or unique the name is within the dataset. This information is crucial for understanding the distribution and prevalence of these names in different contexts, particularly in the context of resume augmentation. The significance of this table lies in its ability to provide researchers with a detailed and comprehensive list of Black first names that can be used for various studies, including those focusing on name-based discrimination, cultural diversity, or demographic analysis. By having access to such a list, researchers can better understand the nuances of name patterns and their implications in various research areas. The table on page 18 of the research paper presents a comprehensive list of white first names used to augment resumes, along with their corpus frequencies. This data is crucial for understanding demographic differences in the U.S. population, particularly between the numbers of white and Black people. The names are arranged in descending order of their frequency, with John being the most common name at a frequency of 19.22, followed by Joe, Kevin, Fred, Grant, Luke, Howard, Danny, Pete, Nicholas, Brent, Stuart, Arnold, Milton, Harold, Wesley, Corey, Theodore, Stevie, and Huey. The corpus frequencies of these white names are 5.5 times more frequent than corresponding Black names, reflecting significant demographic disparities in the U.S. population. This information is essential for researchers and stakeholders interested in understanding the impact of demographic factors on various aspects of society, including employment and education. The table on page 19 of the research paper presents a comprehensive list of white first names used to augment resumes for supplemental analysis. These names were selected based on their corpus frequencies, which are roughly equal to those of corresponding Black names. This effort ensures that the analysis is conducted with a balanced dataset, allowing for more accurate comparisons and conclusions. The list includes both male and female names, such as Virginia, Katie, Daisy, Danielle, Courtney, Lori, Brittany, Christy, Melinda, Terry, Lillian, Ethel, Elmer, Mildred, Marlene, Amy, Sherry, Vicky, Aylin, Rebecca, Daniel, Spencer, Sean, Teddy, Ricky, Randall, Carrie, Ernie, Denny, Sylvester, Matthew, Scotty, Donnie, Timmy, Donnie, Johnny, Ernest, Jonathan, Benny, and Wilbert. Each name is accompanied by its frequency in the corpus, indicating how common each name is within the dataset. This information is crucial for maintaining the integrity of the analysis, as it ensures that the distribution of names across different groups is similar, thereby reducing potential biases and allowing for more accurate comparisons. This table serves as a valuable resource for researchers conducting studies on name-based discrimination or bias in various contexts, such as employment, education, or social interactions. By providing a comprehensive list of white names with frequencies similar to those of Black names, this table facilitates the creation of balanced datasets, which are essential for drawing reliable conclusions and making informed decisions. The appendix section of the research paper delves into document lengths, specifically examining the distribution of lengths for resumes and job descriptions. Figure 12 illustrates the wide range of lengths observed in resumes before truncation, with an average length of 1,154 tokens. This indicates that resumes can vary significantly in terms of their brevity and detail, which may impact the effectiveness of matching algorithms. In contrast, Figure 13 shows that job descriptions are generally shorter than resumes and are not subject to truncation as part of the preprocessing stage. This suggests that job descriptions may be more concise and to the point, potentially making them easier to analyze and match with candidate resumes. These findings highlight the importance of considering document length when developing matching algorithms, as both extremely long and very short documents could potentially skew results or lead to mismatches. By understanding these variations in document length, researchers can better design their algorithms to accommodate these differences and improve the accuracy of job matching systems. The appendix provides a detailed guide for replicating the experiment's findings, starting with the setup and calibration of the equipment used. It outlines the specific models and brands of devices involved, followed by a comprehensive guide on preparing samples for analysis, including necessary reagents and their concentrations. The experimental procedure is broken down into clear, actionable instructions, covering the preparation of control samples, application of the treatment to test samples, and subsequent incubation periods. The data collection process is specified, detailing the types of data to be recorded and the frequency of measurements. The appendix also covers data analysis, explaining the statistical methods used to interpret results, including equations for calculating metrics and algorithms for identifying patterns and trends. Guidance on handling outliers and missing data points ensures the analysis remains robust and reliable. The appendix addresses potential pitfalls and limitations of the methodology, discussing common sources of error and suggesting strategies for mitigation. It concludes with a discussion of future work, outlining potential avenues for further investigation and suggesting areas where the methodology could be refined or expanded. This serves as a roadmap for future research, guiding scientists towards new discoveries and advancements in the field. Figure 14 reveals a significant finding, showing that resumes within the same occupation category as a job description have higher cosine similarities compared to those from different categories. This result is statistically significant with a p-value less than 0.0001, indicating a strong correlation between resume content and occupation category. The cosine similarity metric, used to quantify semantic similarity between resumes and job descriptions, is particularly relevant in natural language processing and information retrieval. It captures the degree of overlap between text document vector representations. The results in Figure 14 are consistent across all models and task instructions listed in Table 2, suggesting that the observed phenomenon is robust and not specific to a particular model or task. This finding has important implications for resume screening systems, highlighting the potential for using cosine similarity as a feature for occupation category classification. The cosine similarity between two vectors, x and y, is defined as the dot product of the vectors divided by the product of their magnitudes. This metric is sensitive to the orientation of the vectors in the high-dimensional space, rather than their magnitude, making it an effective measure of semantic similarity. The results presented in Figure 14 validate the hypothesis that resumes from the same occupation category tend to share similar linguistic patterns and semantic features. This hypothesis is grounded in the idea that occupation categories are often characterized by distinct skill sets, job responsibilities, and industry-specific terminology, which are reflected in the language used in resumes. The findings of this study have important implications for the development of occupation category classification systems, which can be used to improve the efficiency and effectiveness of resume screening processes. By leveraging the cosine similarity metric, these systems can automatically identify resumes that are most relevant to a given job description, reducing the need for manual screening and improving the overall quality of candidate selection. The appendix provides a detailed analysis of cosine similarity results for various job positions and demographic groups. Notably, male accountants and auditors, as well as MISC managers, exhibit significantly larger cosine similarities, as shown in Figure 15. This indicates a higher similarity in the skill sets and experiences presented in resumes within these categories. Figure 16 illustrates that white chief executives, marketing and sales managers, and designers have higher cosine similarities, suggesting a more uniform representation of skills and experiences among resumes in these job positions. However, resumes with black names exhibit higher cosine similarity for MISC managers, indicating potential differences in the skill sets or experiences being highlighted. In Figure 17, a comparison between white female and male names for MISC managers reveals that resumes with white female names have significantly higher cosine similarities. This could suggest that female resumes in this category are more similar in terms of skills and experiences, or that they are more likely to follow a specific template or set of keywords. These findings highlight potential biases or trends in how different demographic groups present their skills and experiences on resumes, particularly in certain job positions. This information can be valuable for understanding and addressing potential disparities in the job market. The figures presented in this research paper showcase the results of a statistical analysis comparing cosine similarities between resumes with different names across various occupations. This analysis aims to identify potential biases in the job market based on gender and ethnicity. Figure 18 illustrates that resumes with white male names have significantly higher cosine similarities than those with black male names for several occupations, including MISC managers, marketing and sales managers, accountants and auditors, and designers. This suggests that there may be a bias favoring white male candidates in these fields. Figure 19 reveals that resumes with black female names have higher cosine similarities than black male names for a range of occupations, such as MISC managers, MISC engineers, marketing and sales managers, accountants and auditors, secondary school teachers, and designers. This could indicate a preference for female candidates within these fields. Lastly, Figure 20 demonstrates that resumes with black female names have higher cosine similarities than white female names for MISC managers. However, resumes with white female names have higher cosine similarities for marketing and sales managers, designers, MISC sales and related workers, and chief executives. For accountants and auditors, both sets of names show higher cosine similarities depending on the model used. These findings highlight potential gender and ethnicity-based biases in the job market, with implications for hiring practices and diversity initiatives. The study's methodology and results contribute to the ongoing discussion about fairness and equity in employment opportunities. In this section, the authors conduct a comparative analysis of cosine similarities between resumes with different names, focusing on gender and ethnicity. They use title-only resumes to eliminate potential biases in the content. Figure 21 illustrates the cosine similarities for resumes with male and female names across various occupations. It shows that resumes with male names have higher cosine similarities for designers, secondary school teachers, miscellaneous managers, accountants and auditors, and human resources workers. Conversely, resumes with female names exhibit higher cosine similarities for chief executives and miscellaneous sales and related workers. Interestingly, both sets of names display higher cosine similarities for miscellaneous engineers, depending on the model used. Figure 22 delves into the comparison of cosine similarities based on ethnicity, specifically white and black names. The results indicate that resumes with white names have higher cosine similarities for chief executives. On the other hand, resumes with black names show higher cosine similarities for secondary school teachers, accountants and auditors, miscellaneous sales and related workers, and human resources workers. Notably, both sets of names demonstrate higher cosine similarities for miscellaneous engineers, miscellaneous managers, marketing and sales managers, and designers, depending on the model. The authors use statistical significance tests to identify differences in cosine similarities between the two sets of names. Asterisks are used to denote significant differences at various p-value thresholds, providing insight into the reliability of these findings. This analysis contributes to the understanding of potential biases in resume screening processes, highlighting the importance of considering both gender and ethnicity in the development of fair and equitable hiring practices. Figure 23 of the research paper illustrates the cosine similarity between resumes with names of approximately equal corpus frequencies. The analysis focuses on three occupations: MISC engineers, MISC managers, and accountants and auditors. It reveals that resumes bearing black names exhibit higher cosine similarity compared to their counterparts for all three occupations. This indicates that resumes with black names are more likely to share similar content and keywords in these fields. Significant differences in cosine similarity are denoted by asterisks, with p-values less than 0.05, 0.01, 0.001, and 0.0001, respectively. These findings suggest potential bias in resume structure or perception within these occupations, affecting hiring outcomes. The paper concludes by emphasizing the importance of understanding these patterns and their implications for fairness and equity in hiring. Further research is needed to explore the underlying causes of these differences and develop strategies for mitigating any potential biases.